Hello everyone, in this video let me show you my facial auto rig for character. Okay, this technique is based on KineFX of Houdini 19. Alright, let's get started. So today's video is not strictly speaking a step-by-step tutorial, but instead I will present to you the whole network and I will go through all the nodes one by one to show you all the settings so that once you have downloaded all these assets, you can connect them like so. So you don't need to watch a very long tutorial for connecting the nodes. For this facial auto rig, you need these 4 digital assets. And if you want to do facial motion capture offline, you need to have this optional additional digital assets to load offline data from CSV files. Let me give you an overall structure of this network setup. So first of all, I have a character. So this is my character model. And for this character, I have separate the primitives into primitive groups. For example, the eyelashes, the hair, the head and eyes, the limbs, the lower mouth group. This is for painting the skin weight inside the mouth, because from time to time you need to hide the lower mouth so that you can paint the upper mouth easier. Same thing, you put those lower teeth into a lower teeth group so that you can easily paint the upper teeth and or lower teeth separately. And also you can separate the mouth inside group, and then you have the other geometry like pants, shirt, sneakers, tongue, and the upper teeth, yeah, so on. Once you have those groups, then basically you can separate them based on how to do the facial expression setup. We will be using KineFX based joint based rigging. We will be mainly rigging the face geometry, the eye, the teeth, the tongue, but not the hair and eyelashes. So here I'm separating the eyelashes here. So here I have a blast node just to keep the eyelashes. Okay, let me hide the other geometries. Okay, and this node is to blast everything else just to keep the hair, and this is to keep only the teeth, the upper and lower teeth. Then you have the face geometry and eyes. Basically this is only the face geometry, not including the teeth, but include the eyeballs. And lastly you have this tongue geometry. Then we will need to merge the teeth, the head and eyes, the tongue into one geometry. Please note that for the facial rigging, all this geometry will be deformed by the joints. And when you merge this 3 type of geometry, the teeth, the head and eyes, the tongue, you need to remember the order, because later when we do blend shapes, the order really matters. Alright, so then from there, we use this data to drive the eyelashes. We will talk about that later. Then from the teeth, go down, because the teeth won't bend or twist or whatever, so we can simply use joint capture proximity capture method. Should be simpler. Another important thing after that is that you need to paint the capture weight so that when the jaw opens, it moves the lower teeth, okay, not the upper teeth. Okay, let me show you let me display the head and eyes. They're supposed to be deformed, so I'm going to use a joint capture by harmonic. Hopefully it can give me a much smoother result. And I'm painting skin weight here, but basically these are all the joints. Okay, all these are orange dots are the joints. We have the digital assets for that. Okay, later I will talk about that also. Okay, the tongue is also going through joint capture by harmonic because it can bend. So by harmonic it will give you a better result. Alright, then you need to paint skin weight also, because the tongue joint consists of a chain of joints. After this 3 group of geometry has been rigged, you need to merge them again. Alright, I have the notes here that these 3 kind of geometry must be merged using the same order as the one on top here. Then everything will go through this joint deform. Okay, it takes 3 inputs. One is the geometry, the rest geometry, the middle one is the capture pose, which is the joints, the rest joints, Then the right hand side is the animated pose, which is the animated joints. Then you get this deformed face. All right. So because I have some animation done already, you can see that when I scrub the timeline, the character is actually acting. All right. So after that, we will be using the data. All right, using this data to drive the eyelashes, because we don't necessarily need to rig the eyelashes, because they are like accessories, can be attached to the face deformation. So after this is done, the eyelashes will follow the eye geometry. When we choose what kind of geometry to drive the eyelashes, actually we are narrow the range down to only those geometry that are very close to eyelashes around the eyeball. Okay, so here, see, I'm only keeping these primitives. Yeah, so these are the rest primitive, and this side will be the animated primitives with the same selection. All right, then when you deform, okay, basically you use this deformation information to drive the eyelashes, okay, so they can follow the eye movement. And then we will merge all this together, because the hair not changed, so the group is just directly merged into here. So now we have this facial expression for this character. Then let's talk about this side. This side, I think, is the most important in this tutorial, which is how we set up the joints, how we rig the joints, how we set up those, how we create those Blendshape data, and so on. Okay, so number one, let me talk about this facial combine control. Yeah, when you select this, actually build this KineFX based viewport controls. So once it's built, then you can actually select the eye, right? I can move the eye. I can animate the eyebrows, lower the eyebrow, for example. Yeah. Or do different facial expressions. This on-screen control is for you to manually keyframe the facial expression. But let's say if you have motion capture data, in Houdini 19, we have this motion capture stream node that can connect to different mocap devices. In my setup here, only live link face is supported and tested. So basically, when you connect to your live link face app from your iPhone, then you can capture your facial data and stream to Houdini through this app. This app is developed by Unreal Engine, Epic Games. When you use this node, actually you can record your performance and output your performance into a sequence of geometry data. Here, I have recorded something and output the data. I'm loading back through file cache here. Data is at the detailed level. So you can see that it has this blend shapes like brow down left, brow down right, inner up, outer up, left, right, so on. Eye looking at different directions, jaw, mouth, and so on. It's the same data that generated by this mocap stream, basically generating all this Blendshape data at the detailed level as well. In another separate video, I presented different method when you want to do facial mocap for a situation where you want someone to record using their phone, not necessarily have to connect to a Houdini. Then they just recorded their facial performance. They can upload the file, give it to you, and when you unzip it, inside there you have a CSV file, consists all the motion capture data, Blendshape data. When you select it, you can see here you have similar kind of names like brow down left, brow down right, and so on, eyes, and so on, right? So this node can load that CSV file, and you can also feed this data into the facial auto rig system that can drive the whole character face as well. So let me show you one example. If you display the final results here, and let me switch to switch to input 3. Okay, input 3 is this offline data I generated through my phone. So when I grab the timeline, you can see that actually it's my facial performance here. Using this system, you can do either keyframe animation or facial capture, even with offline functionalities. Then let's talk about this core of this setup, which consists of 3 digital assets. Number 1, these are the initial skeleton. Basically, I have these assets for you to create all these joints. Basically, you can say for eyebrow, I'm going to create 7 joints. You can change the number here. For upper eyelid, I want to create 6, right? Yeah, you can change the number here based on if your character have a very complicated eyebrow and so on. Then, because this is only half of the face, after you have dropped down this digital assets, actually you can move all these joints to fit to your character. So basically, after this initial skeleton here, you can drop another skeleton node. So here, then you can change to modification mode. Child compensation means I move the parent, the child won't be moving. You need to turn on the tweak mode. Also, freehand, you can now move the joints to where you like to fit to your character facial features. Then after this, everything is done. I will just ignore this. We will connect this asset called add extra joints. Basically, this will mirror from one side to the other and also create this children and parent relationship. See, all the joints, almost all the joints are parent to the proper hierarchy. I think except those 2 eye joints. Then after this is done, we come to this facial auto rig tool. So when you select it, it will take a while to load the interface because usually for Blendshapes, it's quite complicated. For example, in this case, I think I have almost 200, to be exact, 189 Blendshape configurations because some of the facial expression need more joint groups to work together. Let me go through a little bit of how this is set up. Actually, let's look at the final result. Okay, so I have loaded this character. Then let me switch to the keyframe animation and let me show you what happened when you move a controller. When you select this combined controls, you may realize that actually this node will generate those same Blendshape data as well as those motion capture nodes. See here at the detailed level, this control node will be just generating the same like brought down left and cheek, eyes and mouth and so on. When you move the controllers, this data will be changing. And then when you come to this auto rig, it has this different tabs here. Okay, I have a help documentation, very simple one here. So the first tab is the Blendshape configuration. This node, if you don't feed anything into the second input, actually you can turn off this. So you don't need to use animation data from the second input of this node. You turn off this. Then you see the third tab here. You have this animation controls. Actually, these are the individual Blendshapes. You can just change. Right? You see, I changed the value. The eyebrow left, down, then the eyebrow will go down. So this is the individual sliders. This is not very easy to visualize, so that's why I developed this combined control with visual help so that you can use this data to feed into the second input and turn on this use animation data from second input of this node to take advantage of the on-screen controls. Okay, so for Blendshape configuration, I have this gigantic multi-parameters. Each one of this parameter group follow this Blendshape name, say brow down left. Yeah, you can see the full list here. For this group, will only follow this value. And if you affect only this joint group, L eyebrow joints. Okay, so all the joint groups are here. Remember, we have this initial skeleton here, which will create all the point groups for say eyebrow joints, center one or the left hand side one. The right hand side one is created by this node. So after this node, you have all these proper groups for all the joints. So that in this facial auto rig, you can specify the group here. Say for this parameters, will only follow this Blendshape and affect only this group of joints. In order to understand the facial auto rig better, let's create a new rig and start to play with some of the settings. So let's create a facial auto rig. Alright, so let's connect our joints to the first input, then display the new rig. If you look at the switch, it's using the first input, which is the keyframe animation. The keyframe animation is driven by this facial combined viewport controls. Okay, so let's connect this to the second input. I have included one example facial rig into the definition of the facial auto rig asset. So if you choose this preset, it will give you the starting facial rig. If you use the on-screen controls here, for example, the eyebrow, you can see that when you move this control, the joints that driven the facial geometry, they're actually moving. Okay, that's because we have everything set up here. But for us to understand it better, let's clear the current configurations and start from scratch. Click the clear button. Alright, so that we can start building some examples. So create a new one, and of course I want it to be active, and then the Blendshape that I want to use is brawl, the first one, okay, brawl down left, and then I will let this value to drive this one, left eyebrow joints group. The left brow joint group are these joints. Okay, to visualize those joints, you can actually insert rig pose here. Then you can see that these are the joints starting from L eyebrow 0, 1, 2, 3, 4, 5, 6. So in total 7 joints. The number is specified here to have 7 eyebrow joints. The orientation of the joints will follow this way. The negative Z direction will be pointing to the parent joint. Then the Y axis will be the up direction. When you select this rig again, then I would like to use this value to drive the transformation of the joints. To actually make it simple, because this part has some animation here, I can just disconnect this one. Right, I'm not going to use this facial animation for now. I turn off this use animation data from second input. I will just use the built-in sliders. I will not use the on-screen control. I just use the built-in sliders to test the Blendshape data. For example, I want to have this brow down left value to be 1. It's same when you use this from second input, animate this on-screen controls. Then when you have the value but nothing moves, that's because all the mapping from Blendshape value to transformational joints are at default. Let me explain them one by one. Okay, for translation, you have seen this X, Y, and Z axis direction already. So for translation, if you say I want some of the joints move up, then you need to change this ramp graph. Okay, so this is the mapping between the Blendshape value and the joints. Then how to map one Blendshape value to multiple joints is that when you look at the eyebrow joints, 0 all the way to 6, the joints in a group, they have this attribute called adding group together with the name. You can see that for L eyebrow 0 all the way to L eyebrow 6, the ID in that L eyebrow group will be from 0 to 6, right? Then for another group, for example, the upper eyelid group, the L upper eyelid group, right? You have this 0 to 5, 6 joints, and then ID correspondingly will be 0 to 5. See the number actually 0 to 6, 0 to 5, 0. And start from 0 again, right? For each group. So once you have this attribute, let's say for this 7 joints, for left eyebrow joints, you have 0 to 6. Then ID is from 0 to 6, right? See here, 0 to 6, 0 to 6. Yeah, you have once you have this information, then when you look at this ramp, you know the ramp inputs here is 0, right? You select this. This is position 0, and this is position 1. Okay. Then internally we have a mapping from this ID in group 0 mapped to this 0. The last one is mapped to the 1 value. Okay. Then anything in between, like 0 to 6, right? Anything in between will be just mapped accordingly, right? For example, if the 3 is halfway, and it will be mapped here. So that's horizontal input. And for the vertical values, because I want the joint to have the ability to move up and down, so that's why I make this 0.5 value as the default value. If you want any joints to move up, right, you need to increase the value above 0.5. If you want any value that is let me actually better do it at the Y translation, because this is the broad down movement, right? For the first point, I want it to move down. When you move the point down, it seems like nothing is moving. That's because the Y translation ramp will work together with the Y translation multiplier. So this multiplier will multiply this value. And for now, the multiplier is 0. So whatever value you have here will be multiplied by 0, becomes 0. So let's give it a value of 0.1. Yeah, then you can see that actually the point will move. For this ramp, maximum it can move to 1 from default 0.5, which is it moved to 0.5, and then this value will multiply by this 0.1, will end up being the end result movement in the Y direction. And if you move down, it will move down. How about let's take a look at the if we use this value to drive the character. Okay, because for now it doesn't drive anything. So let's connect this to our new rig node and display the character. Then go back to this rig here. I can see that if I move this side, remember the joint with ID 0 is on this side, so it's moving. This side is moving. But if I move this side, and this side will move, because we're supposed to do brow left down, so we'll move the whole brow. Of course, you can insert more points, so you have more control different locations. Say if I want to have a different shape of the eyebrow, you can do so, and you can even change it to like spline smooth curve. This will go down a little bit lower than 0.5, so the whole brow is going down. Then if you look at the animation, okay, this is 1, the Blendshape is 1, right? If Blendshape is 0, everything go back to default. But sometimes when you need to look at the say from the side view, you might want the joints to move in Z direction as well. First thing, you need to give some value here, the multiplier. Then you're going to move, yeah, right. So the Z direction will be this way for positive and this way for negative. Other than move in the Z direction, you can also move in the X direction. Say if you want the eyebrow to move inside, you keep some value here, right? Then you can just tweak the value accordingly. And also you can have a rotation for individual joints. You want them to rotate a little bit. It's more useful when you're doing lips. Say you want to roll the lips a little bit, but for the eyebrow maybe I don't need it too much. You can see that the default value is at the middle, 0.5. Again, if you make it larger than 0.5 means rotate in one direction, and lower than 0.5 means rotate in the other direction, of course, and then they will multiply with this multiplier. The same thing for XYZ rotations. And for the scale, it's for when you mainly when you do lips, right? You want to sometimes press the lips together, then you want to scale the joints in y direction, for example. For the scale, usually the scale default value is 1, it's not 0. And when you move up, that means scale up. When you move down, below 0.5 means scale down. And then this value will be multiplied with this multiplier again. Actually, the idea behind this tool is quite simple. You need to have quite a lot of mapping from Blendshape to transforms to make it work. For the example precisely, I did 189 of them. Then we have other two check boxes. One is hierarchical, and the other one is a compute xform from input and output. Let me explain this first. Compute xform for inputs and outputs. If you look at my joints for the eyebrow, for the eye, right? Actually, the joints independent from each other within the group, and none of the joints has children joints. So the transforms of these joints can be calculated independently and in parallel. In this case, you don't need to turn down this option because there's no children joint to update. So you don't need to calculate the xform for input and output. The other hierarchical checkbox is for the situation where you have all the joints in the group in a hierarchical manner. They cannot be calculated in parallel. They must be calculated one by one. We will create examples to further explain that. Let's create a new group of parameters for tongue up, and of course this Blendshape will be applied to central tongue joint. To configure this Blendshape, we need to make sure that we go to anim controls and go to the tongue up. Make sure that the Blendshape value is 1, because this is the control for this Blendshape. If you don't put it as 1, your configuration will not take effect. So let's take a look at the joints here. The tongue joints are here. Tongue 0, 1, 2, 3, 4, 5 of them. And you can try to do rotation around x-axis. If we give some value here, then try to rotate the joints around the x-axis. It seems like nothing happened, but actually there's something going on. Okay, let me just look at the final result here. Then let's select the tongue, but the linear selected. Right, so we are looking at the tongue here, and if you look at the value now, actually when you changing the value, actually the joints are rotating. It's just like no parent and children relationship between them. They are calculated independently. Apparently this is not something that we want here for the tongue. If you turn on the hierarchical, they will be calculated one by one, so they are aware of other joint changes. Of course, we need to turn on the compute xform for inputs and outputs, so that once the parent is processed, it will update the children joints. Next, let's take a look at the draw open and close. So let's create a new group of parameters. That this way will look at the draw open, and they will apply the transformation to the draw joint. Of course, let's look at the whole head. So now we know that for the draw joint, we want to rotate around the x-axis. So we look at the x rotation, but we need to give some value first. Then we can let it to rotate. Of course, it's not rotating because we need to increase the Blendshape value. Draw open. Then we will let draw to rotate. Because the draw is only one joint, it's not a group of joints. So actually the ramp, right, only take one input. So actually we don't need this value here. We just need one value. But when you rotate the draw, how come the lips not following? So what you need to do is to turn on compute xform for inputs and outputs. So now the lower lips and lower mouth joint are following the draw joint movement. Say for example, I want maybe rotate a little bit even more like this. Say that's the fully open. Or actually you can give a one value, then adjust this multiplier. So this is the draw open facial expression. So when animator animate this, they will have this draw open animation. So that's animating without the second input. Just use this node itself. But if you want to use the on-screen combined controls, you can connect it here because the switch is already taking the input from 0. If you connect the switch to the second input of our new node, and if you turn down the viewport controls, you know that when you move your cursor closer to this area, you have this controller for jaw movement. Select that, and you can move up and down, but it's not working, right? That's because for your new node, you need to tell the node that use the data from the second input, not the data on the node itself. So you need to turn on this. So now when you go back to the on-screen control, you can control the jaw open. So we have configured 3 things. Number 1, brow down left, which is this control will control brow down left. And also we have tongue control here. You select that. And when you do tongue up, this is not properly configured, I believe. So this will rotate in this direction. So this means that during the animation, if you don't like the movement of the joints, you can come back to configuration and tweak some of the settings. And you go back here again, control the tongue going up and down. Let me zoom in a bit. Yeah, going up and down. All right. And of course, we have done the jaw open. I will just give you this 3 demo. Now let's take a look at the second tab here. We know that the first tab is the Blendshape configuration. The second is the input animation data modifier. That means that sometimes when you have a motion capture data coming in, maybe the actor is different from your character. Then when they do the brow down left movement, is too exaggerated, and you don't want that too much, or you feel like too subtle, then you want it to be more exaggerated, and you can use this modifier. Not necessarily have to go back here to actually change your configuration, because this configuration might be something that you prefer, but then suddenly you have motion capture data coming in. The way they capture the data is like too subtle. You want to exaggerate it more, then you can use this tab here, modifier tab here, to exaggerate it. Let me give you an example. For now, this switch node, right, is taking the inputs from a facial animation. Let's switch it to this motion capture data. Of course, you can use other mocap stream data, but I'm just using this offline data reading from CSV file. I need to switch to 3. Then this character should have some facial expression. Because remember, because we only configure 3 things, so most of the facial expression are not there. But at least the jaw open, you can see that the jaw open is there. There also, in this time period, there's also movement on the left side eyebrow. This is the motion capture data. If you think your configuration is good, you don't want to change that, but you just feel like the motion capture data is too subtle, then you can come here to exaggerate it more, because this is scale for brow down left. So you can increase this value, right? Increase this value to multiply the Blendshape data with this value. I'm going too extreme. Let's go back a little bit here, for example. Then of course you can also do offset. In some situation, you may want to shape the whole value up or down. So for each of the Blendshape data, I will have 2 modifiers for it. One is the scale, one is the offset. Okay, I think that's all for the simple demo. Let's switch back to the fully functional facial auto rig configuration. As I said, if you do everything from scratch, you will do a lot of this mapping from Blendshape to joint transformations. But again, I provided one preset for that. If you click here, you will get exactly what I have on the other node. Consists of 189 these mappings. Let's move on to capture layer paint node. Capture weight painting is also very important. Because you have so many joints on the face, you need to paint the capture weight properly and make sure that they are smooth. If you look at this say for the eyebrow, this is for the L eyebrow 0, L eyebrow 1, L eyebrow 2, L eyebrow 3, L eyebrow 4, L eyebrow 5, L eyebrow 6. So I have a 7 joints from 0, 1, 2, 3, 4, 5, 6. So after you paint the weight, you make sure that you need to smooth them out. And for the tongue, I think it's quite straightforward because you can see that we have a curve of joints that you just need to make sure that the capture weights are smooth. That's the very quick introduction to this facial auto rig assets. So hope you like it, and if anything, please let me know. Thank you so much. See you next time.